Hello, grade 11 students. Welcome to our new session about the pedigree. Here we continue with our chapter, the genetics. So first, what is a pedigree? Pedigree is known to be the genetic representation of the family tree, the tree of the family. This will show the inheritance of specific traits or disease through the generation from the generation 1, 2, 3, 4, and so on. So this pedigree shows the relationship between the family members and indicate which individual they express or they carry this trait, but they carry it silently as it's masked in the parents. So this is the pedigree. This is the shape of the pedigree. First of all, the pedigree should be drawn using a pencil. Second, it should be closed with a box and given a title. Always the circle will be for the female and the square it's for the male. First, we have the first generation, so they gave it the symbol I. I is not I, this is 1 in Roman. And this is number 2, the second generation. And this is the third generation. And this is the fourth generation. So for example, if I want to name the first member, this is a male, so you gave it, for example, 1, 1. And this is 1, 2. And this is 2, 1. This is 2, 2. 2, 3. 2, 4. And so on. And this is here 3, 1. 3, 2. 3, 3. And so on. And here we have 4, 1. 4, 2. And also so on. So this legend is very important. We have to use it. So it has said here, according to a specific trait, the blue circle is for the normal female. So here, these are normal females, for example. And the square is for the normal male, the blue square, while the red square for affected male, and the red circle is for affected female. So this is the legend that is given in the. So here we have an application, and during this application we're going to explain this pedigree. Sarah and Maher, both of them, they are normal, so they don't have any problem or any disease. They have a family history of albinism. What is the albinism? Albinism is a disease where the melanin is not produced. This will lead to the lack of pigmentation of the hair and skin. Here are albino. So the person that has albinism is said to be an albino. So he has a problem in the melanin. So this leads to absence of pigmentation in the skin and in the hair cells. Also, this is the albino. They have mostly the white hair. So this is albinism disease. So Maher, they gave birth to 4 children. Ahmed, which is a male, Jack, also male, Mary, female, and Fatima. All were normal, except Jack, who turned out to be an albino. So Jack is an affected individual. Part 1, they want us to construct the pedigree or the family tree representing this family. So Sarah and Maher, they gave birth to 4 children. We're going to represent them. All of them, they are normal, except for the person which is an albino 1. Determine the dominant and recessive. We have to determine it according to the pedigree, and we have to justify our answer. Designate by symbols the corresponding alleles. Determine the possible genotypes or genotypes of the parents and their children, and then we have to perform the essential factorial analysis to verify these results. Let's start step by step. Here, notes before we start. Every time we have a circle, this is for a female. Trait 1, let's say trait 1 is the normal. So trait 2 is going to be the affected or disease or abnormal, while the square is for the man. Trait 1, let's say it's the normal in this case, and trait 2 is for the affected. Whenever with us this rhombus, for example, is for fetus. Whenever we see a male and female and they are connected with a line, this means we have marriage. Relative meeting or consanguineous meeting is for meeting between relatives, okay, cousins and so on. So they put the same, but they put two lines in the middle. Here we have children. So for example, we have two couples, they marry and they give birth to children. And here, whenever we see this for twins. So this is the pedigree. Always and always, this pedigree is going to be like this. So Maher and Sarah, they marry and they gave birth to Ahmad, Fatima, Mary, and Jack. You have to give the legend here. So the legend is the circle, the white circle for normal woman, the white box for, or the white square for the normal man. Albino man is the box that is filled with the colored blue. Here we don't have an albino woman, that's why we didn't put. And there is the title, you can put it under the pedigree. And the pedigree, you have to close it using a pencil and a ruler inside a box. Here we have in this pedigree. Let's give, for example, the symbols. Symbols for the male, for the alleles of the albino and the normal. But before we give, Maher and Sarah, both of them, they are normal. But they gave birth to affected individual Jack. So the allele of the disease, it was masked in the parents. So it is recessive with respect to the normal dominant allele. So dominant is normal. So let's give for the normal the symbol N. And for the allele of the disease, let's give it the symbol A small. First of all, Jack is affected. And the allele of the disease is recessive. So it should be expressed only in homozygous. So let's give N capital. Sure, you have to give, let N be the symbol of the allele coding for the normal, which is dominant over the recessive allele of the disease. So N for the normal, and let's give A small for the albino individual, or for the albinism allele. So here for the affected, or the albino, or the albinism. Okay, so first, Jack is affected. So the genotype should be A small, A small. We don't have other chance, since the allele of the disease is recessive, and it should be in the homozygous state. Maher and Sarah, they are normal, as well as Ahmad, Fatima, and Mary. First of all, Maher is normal. So sure, Maher has the N allele, the normal, which is the dominant, but also Sarah has the normal allele. Jack has two alleles, A small, A small. So Jack will inherit A small from the mother, from Sarah, and A small from the father, from Maher. So both of them, they are heterozygous, having genotype N capital A small and N capital A small. So they carry the allele of the disease, but it was masked in the parents. What about Ahmad, Fatima, and Mary? Ahmad, Fatima, and Mary, they are normal. So they carry the normal allele. So all of them, they have N, and N. But wait a minute. They inherit N from one of their parents. From the other, they may inherit A, or may inherit N capital also. So maybe it's NN or NA. And here, maybe it's NN or NA. Also here, NN or NA. Since they may inherit N from the father and N from the mother, or they may inherit N from the father and A from the mother, or the opposite. So here, we're still confused, but what we have to know is that they have the allele N, which is for the normal. Here they have two possibilities, Mary, Fatima, and Ahmad. Here, since Maher and Sarah, they are normal, but they gave birth to albino Jack. So the parents, they carry the albinism allele, but it was masked. Very important word here. Masked by the dominant allele, which is for the normal. So the normal allele is dominant over the allele of the albinism, which is recessive. Let N capital be the symbol of the normal allele, which is dominant over the recessive allele of albinism, and let A small be the symbol of the allele of albinism, which is recessive with respect to the normal dominant allele. Part 4, we have to give the genotype. So Jack is albino, and the allele of albinism is recessive, and can be expressed unless in the case homozygous. So the genotype should be necessarily a small. Maher and Sahra, they gave birth to albino Jack. So they must carry the allele of the disease, but it's masked by the normal allele. So they are heterozygous or hybrid, having genotype and capital A small. So normal allele is dominant. It can be expressed in homozygous or heterozygous. So Marie, Fatima, and Ahmad, they could have received 2 alleles N from each parent, or 1 allele N and 1 allele A. So their genotype, they could be either pure N or hybrid and capital A small. So this is the possibilities for Ahmad, Fatima, and Mary. Part 5, they need to perform the essential factorial analysis to verify the results of Sarah and Maher. Sarah and Maher, they are normal. So they have genotype and capital A small. Let's start. Here we have normal and normal. So let's start first with the phenotype. This is the factorial analysis steps. Male cross female. Both of them, they are normal. So normal male and normal female. And then we move to the genotype. So in the genotype, both of them, they are heterozygous. They are N capital A small crossed with N capital A small. Gametes of symbol gamma. So here we have 50% N, and they have 50% A. And crossed with what? With the female, it will be N, and here it will be A, also 50%, 50%, and here we forgot to put 50%. Table of cross, it should be like this. Cut it to 2. And this is the table of cross, male and female. Here we have what? N 50%, A 50%, N 50%, and A 50%. So N, it's a 25%, NA 25%, NA also it's 25%, and AA it's 25%. So here we have NN 25, which is normal, NA 25, which is normal, NA also 25%, which is normal, and AA 25%, which is normal. If I want to work also with proportion, it should be here 1/2, and 1/2, 1/2, and 1/2. If I want to work with proportions, and here half, and half, and here half, and half. So if I want to work with proportion, this should be 1/4, and this should be 1/4, and this should be 1/4, and this should be 1/4. So 3/4, they are normal, while 1/4, it's affected. So let's continue with the table of results. So in the table of results, what do we have to do? Table of results, so we have to put genotype and phenotype. So genotype, we have NN 25%, NA it's 50%, and we have AA 25%. So here total 75% they are normal, or as I said, if you want to work in proportion, it's 3/4, and 25% albino, or they have albinism. So here 3 out of 4 of the children they are normal, except Jack with an albino 1/4. So therefore results are verified. That's it. Thank you. Bye bye.